Welcome back, everyone. We're going to learn how to multiply polynomials. So a couple things to keep in mind is that in order to multiply polynomials, you would need to know the rules of exponents, some of the basic rules of exponents, and the distributive property, okay? So we'll talk about those as we go along. So we'll do some examples. Very first example is 3x squared times 5yz to the fourth power, okay? And what we want to do is we want to multiply, the first thing I'm going to multiply, okay, would be the coefficients. Okay, 3 times 5, okay, would in fact give me 15, okay? And then we're going to multiply the variables together. And I'm going to write them in alphabetical order, okay? So I'm just going to write that in that standard form so it's easy to read. So x squared times y times z fourth. Since all of those are different exponents, we can't combine the exponents. So we're just going to write, we're going to do x squared times y and then times z fourth. And when you do that, you're going to get x squared y, c to the fourth. Just put the variables together like a times b. For example, a times b is just going to be ab, okay? And that's the answer for that. So pretty simple, okay? So we're going to do more. M squared n to the third power p. All right. So again, we're going to start with the first variable m, okay? And we're going to multiply that m cubed times m squared. So when you do that, okay, keep in mind that negative m cubed times m squared. So I'm just doing this one variable at a time. And the rules of exponents is that, we take, when you have the base, which is m in this case, when they're identical, okay, they both have the same variable, we go ahead and add the exponents, okay? So now remember, a negative m times a positive m is still negative, okay? So then we want to do is take the m, and then we add the two exponents. So my answer is going to be negative m to the fifth power. You take the 3 and the 2 when you add those two exponents because you're multiplying the same variable, okay? You just attach the negative to it because a negative m times a positive m, remember, gives you a negative. So you just got to remember your signs, okay? So negative m cubed times m squared is negative m to the fifth power. All right, so let's do the other one where we have n 7th power times n cubed. So we'll do that over here. We have n to the 7th power times n to the 3rd power. All right, so we can write that as one base and then just go ahead and do 7 plus 3, which we know is n to the 10th power. Okay, so we're going to add n to the 10th power. You notice I'm just putting all the variables next to each other because that's what you do when you multiply different variables. And then the third thing is that we're going to take the p to the 6th and we're going to multiply that by this p here. Okay, so we can do that work here. P to the 6th times p. Now there's an imaginary exponent with this p, so I'm going to put it here so you see it is there. So again, we're going to add 6 plus 1. We have to add that imaginary 1 there, so don't forget. So then you're going to get p to the 7th power. All right? So p to the 7th power, and then this is your answer. Okay? So that's how you multiply polynomials. You have to keep in mind the rules of exponents. Okay, so let's try another one. All right, we have a to the 10th, b to the 11th, c to the 12th. We're going to multiply that by a, b, c, minus 1/2, b to the 7th, c cubed. All right? So what we're doing is we're doing the distributive property. We're multiplying everything outside the parentheses with everything inside. All right? The only difference is you have multiple variables outside the parenthesis, but that shouldn't matter because we're going to do one variable at a time when we combine the exponents. All right? So why don't we just start with multiplying the first term. Mm-hmm. So we're going to multiply a to the 10th and b to the 11th and c to the 12th by ABC. So we'll do that first. Okay? So when we multiply a to the 10th and a, you got to remember that a to the 10th times a, there's an imaginary 1 there. So when we add the exponents, 10 plus 1 will in fact give me a to the 11th power. Okay? So we have to be really careful with that. All right? So I'm going to go ahead and put that in there as a to the 11th power. Okay? Now the next thing that we're going to multiply is b times b to the 11th times b. So when we have b to the 11th power times b, again there's an imaginary 1, so it's b to the 11th and then plus 1. So that would be b to the 11th power as well. Or 12, I'm sorry, 12. Okay? Why did I say that? I don't know. Apologize. Okay, 12. B to the 12th power. Okay? So we're going to replace that with b to the 12th power. Okay? Then we're going to multiply c to the 12th times c. When you do that, c to the 12th times c, there's an imaginary 1 there. So we can write it as 1 base and then just add 12 plus 1, which is c to the 13th power. Okay? So, and that's what you get when you take a to the 10th, b to the 11th, c to the 12th, and times it by ABC. Okay, now the next sign here is negative. Okay, and then we're going to take a to the 10th, b to the 11th, c to the 12th times negative 1/2 b7 c cubed. We have to do it by the second term, so it's kind of like a double whammy, right? So when we do that, okay, we take the a to the 10th and we're going to times it by this whole thing. Okay? So since there's no a term in the negative 1/2 b to the 7th c to the cube, we're just going to attach it there. Okay? So it's just going to be, let me go ahead and write it in red. So negative, so we don't get confused. Okay? So negative 1/2 and we're just going to add the a to the 10th, okay, because there wasn't an a there, so we'll just attach it to it. All right, and then we want to multiply the b to that as well, and then just becomes, well, don't forget, you got b to the 11th and b to the 7th. So when we do that, b to the 11th times b to the 7th, okay, we're going to add 11 plus 7. Okay, and that should give me 18. So we are going to write that as b to the 18th power. And then our final multiplication is the c, and we're going to multiply that with everything here. Okay? And when you do that, you are multiplying c to the 12th times negative 1/2 b 7th c cubed. So we're going to do c cubed. All right, so that just becomes 12 plus 3, and that's c to the 15th. Okay? And we put that over there. And that would be your final multiplication. So I color-coded it so you can see what I'm doing. All right? And that would be your final answer right there. Okay? This whole thing. All right? Let's do another example. What happens when you have two binomials being multiplied together? Now, this is going to require a method called FOIL. Okay. And what that stands is first, outer, inside, and last. Okay. So what we want to do is we want to use this very specific pattern when it comes to two binomials. Okay. The very first thing to multiply is this, and that's called your first term. First term of the first binomial and the first term of the second binomial. So x times x would in fact give me x squared. And you got to remember, y is because you have x and there's an invisible exponent of 1, and you're multiplying it by another x with another variable x with an exponent of 1. So when we add the individual ones, we get x to the second power. That's the justification behind it. Okay? As a matter of fact, I can go ahead and color code this as well. So that is your f. The next thing I want to do is the outside. Okay? So we're going to take x and multiply it by the 7. Okay? So what we're doing over there, an x times a minus 7, you just put them together and it's basically minus 7x. Okay? So when you do minus 7 times x, you just put them together, minus 7x. All right? And that's the outer. And then the inside, okay, will be this, the 5 and the x. Again, you multiply them together, you're going to get plus 5x. Okay? So 5 times x will give me 5x. All right, and then the last, okay, will be these two multiplied together here. All right, and when you're doing that, 5 times negative 7 is negative 35. Okay, and that is your answer for that. Okay, that's called the foiling. We're going to do a lot of that when we do factoring. of trinomials, where we want to break down the two factors being multiplied, which would be the product of two binomials. Okay, and there's all different types, you know. Sometimes you can get difference of perfect squares and all that, and that'll be discussed in factoring. But we will be using FOIL again when we talk about that. Okay, so let's do another one. Okay. All right, we're going to apply the FOIL again. Okay, so that way, you know, we keep track of exactly what I'm doing, so you know. Okay, so the first thing I'm going to do is the first 3x times x squared, and when you do that, 3x times 4x rather, you add the exponents. Well, 3 times 4 is 12, and then you do x to the first plus x to the first, right? There's indivisible ones here, so when we add them up, we get 12x squared. So that's the justification of that, so 12x squared. The next thing, we're going to do the outer, and that is 3x times negative 9. So 3x times a negative 9. Well, a positive and a negative is a negative. 3 times 9 is 27. And then you just attach the x variable to it, and then you're done. Well, done with that step, not done with the problem. The next thing is we're going to do is the inside. Okay, so again, that's just negative 2 times 4x. Again, a negative and a positive is a negative. 2 times 4 is 8, and then attach the x. Okay, so that's just going to be a minus 8x. And then, of course, we do the last, which is negative 2 times a negative 9. A negative and a negative is a positive. 2 times 9 is 18. And now we have all of the multiplication done. However, in this particular problem, there's one more step. Okay, and that is to combine like terms from here to here. Those two terms are identical because they have the same x variable. Even though the coefficients are not, they don't have to be. As long as the variable that's attached to them are the same, we can combine the coefficients. And then when you do negative 27 minus 8, you get minus 35. Okay, so the final answer for this will be 12x squared minus 35x plus 18. And that would be your final solution or simplified solution. Okay, so foiling is pretty easy. Okay, and you will see that so sometimes you'll get a trinomial. Okay, there's another example I wanted to show you. And let's say you had this scenario. We have 2y minus 6x times 2y plus 6x. And we're going to go ahead and apply to FOIL. Okay. So we're going to do F O I L. So the first thing that we're going to do is the first, which is 2y times 2y. All right, 2 times 2 is 4. And then y, we're going to add the two exponents, so it'll be 4y to the 4th. Okay? I'm sorry. why did I say 2? Y to the first plus, yeah. The indivisible exponents are 1 here, 1 here, and a 1 there. So when you add the exponents, 1 plus 1 is 2. So 4y to the second power. That's what I meant to say. Okay, so we're going to go ahead and replace that with here is 4y to the second power. Then we're going to do the first, which is 2y times 6x. And 2y times 6x is going to be 12, positive 12, x, y. We just combine the letters, put them next to each other in alphabetical order. X times y is xy. Okay, and then now we do the inner. So negative 6x times positive 2y. First of all, the negative times a positive is a negative. 6 times 2 is 12, and then x times y is xy. All right, and then our last is going to be negative 6x times positive 6x. And that's going to give me, if we do that over here, remember, negative 6x times a positive 6x. Remember, a negative and a positive is a negative. 6 times 6 is 36. And then we're going to add the indivisible ones. So it'll be negative 36x to the second power. Okay? And that's what's going to go here. Oops, sorry. And then our final step is to see if we can combine any like terms. Well, I do see two terms that both have x and y in it. And you notice that plus 12 and minus 12 will cancel each other out. It's kind of like having 12 apples and then you take away 12 apples. You should have 0, right? Cancel. So this is going to simplify to 4y squared minus 36y. 36x squared. Okay? And that would be your answer. And when you multiply a binomial times, when you multiply two binomials and the middle term cancels and you no longer get a trinomial, that is called the difference of two perfect squares. Because a perfect square is something times itself. Like, for example, 4y squared. Well, in order to get a 4, you need to multiply 2 times 2. In order to get the y squared with it, it needs to be y times y. So I'm multiplying the same thing together. The difference, well, there's a minus there in between those two terms, and then 36. Well, what times what gives me 36? It was 6. What times what gives me x squared? It was x. So that's called the difference of two perfect squares, and that will always be the case when you FOIL them out. The middle term will just cancel, and then you're just left with a squared first term and a squared second term, and the difference of those two. Okay? So it's a very unique pattern that will occur when that happens. All right. Okay, so let's do just a couple more examples, and find the area of the rectangle. So we have a rectangle. All right, and we're going to give you the dimensions. So we have 2x plus 5, and this would be x plus 3. Again, if it's a rectangle, then this side will also be 2x plus 5, and this side will also be x plus 3. Okay? Because you have equal sides. All right? Okay. And you want to find the area, so you're going to have to express this as a polynomial because we don't have dimensions like numerical dimensions. All right, and I'm not asking you to find those dimensions. All right, not yet. We need to know the formulas of basic geometric shapes, right? And a rectangle, if you remember, the area of a rectangle, okay, is going to be length times width. Okay? So here, the length is going to equal 2x plus 5 because it's always the longest side. The side that has 2x plus 5 is longer, right? And the width is going to be x plus 3 because that is the shorter side. Okay, you can clearly look at the rectangle here, and the sides that have x plus 3 are shorter than the sides that have 2x plus 5. So identifying the length and width are pretty straightforward, okay? You just need to know the formula of a rectangle. Same thing for a square, it's length times width, or side squared because all the sides are identical, okay? And then you would just go ahead and multiply. So remember the area, we'll do it over here. The area is your length times your width. So remember that your length in this problem we said was 2x plus 5. And your width for this problem we said was x plus 3. And all that's going to equal the area. So again, what are we doing? We're foiling. You remember foiling? Okay? And then you just apply it like I taught you previously. So the first terms will be multiplied. So I think we can go ahead and do this verbally. 2x times x is going to be 2x to the second power, because I'm adding the invisible 1, exponent 1s with the x's. So 1 and 1 gives you 2. The next thing, I want to multiply the outer. That's 2x times 3, which will give me a plus 6x. Okay, is everybody with me and see that? 2x times 3, 6x. The next thing, we want to do the inside. 5 times x is just 5x. And then the last is 5 times 3, which in fact will give you 15. Okay? Just make sure that's okay. All right. And then we're going to go ahead and combine like terms. Well, 6x and 5x are identical terms because they both have x in it. So the final answer is 2x squared plus 6x plus 5x is 11x plus 15. And this is still equal the area. Okay? And the area can be expressed as that polynomial. Because if we multiply the length and the width, we get that polynomial. Again, we don't know the dimensions of x. We don't know the numerical values of x. We really are not interested in that this time. We just want to go ahead and express it as a polynomial. So the area would be 2x squared plus 11x plus 15, and then you would be done. That would be the answer. Okay? Let's do one more like that. That's a little bit different here. So the perimeter of the square is 76 centimeters. And then I want you to find x. Okay, so let me give you the diagram that's needed. Well, if it's a square, all the sides have to be identical. So whatever one side is, they all have to be the same thing. So one side's x plus 5, all four sides have to be x plus 5. That's with any square, okay? Because all the sides are equal. All right, we need to know the formula for perimeter of a quadrilateral, sorry, can't speak today. So a quadrilateral, the formula for a perimeter of a quadrilateral, okay, is going to be this. P equals, okay, in this case, 4s, meaning four sides. It means we're going to sum up the four sides because a square has all equal sides, okay? A rectangle is a little different, right? The formula for the perimeter of a rectangle is P equals 2L plus 2W, the two lengths plus the sum of the two widths, okay? And therefore you get the perimeter for that. But this is a square, so it's just the sum of all four sides, or 4 times S. And you can name the side any variable you want. We're just going to pick S for this problem, okay? So we're given a piece of information, okay? P in this case is 76, and we know that from here. So we're going to substitute that into the formula, okay? And we're going to say 76 equals 4. And then we know the side. One of the sides is going to be x plus 5. Just look at the diagram. All the sides are x plus 5. So we have 4 of them. So we want to do 4 times x plus 5. Okay? So I'm replacing this s with x plus 5. And now I can go ahead and solve for x. So what am I doing over here? I'm going to distribute the 4 and the x, and I'll get 4x. And then I'm going to distribute the 4 with the 5, and then I'm going to get a positive 20. Then it becomes a simple algebraic equation where we isolate x on one side to solve it. Since the x is on the right side, I'm just going to go ahead and subtract the 20. That way the 20s cancel. 76 minus 20 is 56 equals 4x. Then I divide both sides by 4 so that the 4's will cancel. And then I'm just left with x equals, and 56 divided by 4 is in fact 14. So so x is 14, okay? 14 centimeters, that's what x is, okay? If you wanted to find the length of the side, then you just plug it in, all right? If x is 14, then 14 plus 5 gives you, what, 19? Okay. And then when you add all those up, okay, you're going to get 76. You should get the perimeter back, okay? But this is the answer that I'm looking for. And pardon me for that mark here. Okay. All right. Well, I hope that this video was helpful in determining a little bit about, polynomials, how to multiply them, things to look for, a couple of word problems. Thank you so much and have a great day.